Hello Science 30s. In this video we're going to be talking about nuclear fission. So in fission, guys, what we see is we see the splitting of large nuclei into smaller nuclei. It's going to release energy and it is controllable. So these are the types of nuclear reactions that happen at nuclear power plants. Fusion, on the other hand, is going to be the joining of two smaller nuclei. This is going to release, instead of just energy, this is going to release lots of energy, so it's a lot more energetic than fission, but it is uncontrollable as far as our current technology goes. So this is the type of reaction that happens on the sun. We can't control that reaction, and so we do not have control to do that reaction in nuclear power plants. I just wanted to, hopefully this works, I wanted to show you guys a little demonstration of what this looks like. And so this is fission. And so what you have happening is, here is your, you always have to have something that starts the reaction, and in this case it's a neutron. So there's your neutron coming in, hitting this big nuclei or nucleus and turning that into one and then two nuclei. But then you notice something else coming off of there. It's not just the two nuclei, it's 1, 2, 3 neutrons come off of there as well. And so that's also important to realize. So what we're going to do is we'll look at a question here now that I made up. Okay, so what is the unknown product in the following nuclear reaction? And so what we have is we have uranium 235 is getting bombarded with a neutron, and the product from that is 3 neutrons. Very important to always remember that coefficient, plus an unknown, plus barium-141. So then our question is, how do we figure out this unknown? What is this going to decay into, this uranium-235? So this is no different, guys, than your alpha, your beta radiation questions. You still work with your numbers that are given to you. So in this case, 235 uranium, that mass number, well, there is a plus there as well. So 235 plus 1, so those are these two numbers, 235 and 1, okay, is going to decay into 3 neutrons. So remember, here's your 3, and each one of those has a mass of 1. So there's your 3 plus A plus 141. Okay, we'll go ahead and we'll do this one first, okay? So we're going to land up with 236 on this side is going to equal 144 plus A on this side. So that means that A is going to equal 236 minus 144, which will equal 92. Okay? So that's our mass number. So there's our first thing we need to do. The second thing we need to do is those bottom numbers. 92 plus 0 is going to equal, now we go back to this 3 up here, 3, but it's 0. So that's going to be 0 plus Z plus 56. Okay, so now we know that Z then has to be 92 minus 56, which is going to equal 36. And now we have our answer already, but I mean, let's put this together. So here's our atomic number. Atomic number 36 is krypton. So that's krypton 36 with a mass number of 92, or number of nucleons equal to 92. So now we can finish this up with having our final answer. Our final answer, we'll put in blue for the heck of it here again. We'll change colors, and this is going to be, oh, I keep hitting it here. Give me a second. There we go. So this will be uranium 235 is going to get hit with a neutron, which is going to create 3 neutrons to be knocked off of that big nucleus. or out of that nucleus. And our A, our unknown here, which was going to be the 9236 krypton. And the other one, which we already knew, which was the one barium 141. And there we are. So that's how you're going to handle, guys, all of your fission questions. It is simple math, guys, but you do need to be organized in how you set it up.